All right, recording this video to show the latest changes to my project. I've since the last video I renamed it from gpu-warden to Squire. The reason is that I have a roadmap of several new features that I'm going to implement in a phased approach. And spoiler alert, in the future I don't just want to monitor GPU usage. I want to look at other utilization metrics. So Squire seemed a little better name than gpu-warden. I didn't want the project to be bound to GPU monitoring, so that's why I did that. Okay, so first thing we're going to do is you'll notice that the Git repo is now github.com/lmsilva/squire. We're going to start by cloning it. And still have the same type of scripts as last time for gpu-warden. The only difference is that it's now Squire branded, so it's no longer gpu-warden env or warden env. I apologize. So anyway, what we're going to do is we're going to run this dev tunnels, and we're going to set up some port forwarding. The reason for it is that I run my Kubernetes cloud Kubernetes cluster on the AWS cloud. And because of that, I need to set up some port forwarding so I can reach the Slurm REST API, Prometheus to retrieve DCGM telemetry metrics from it, and Grafana in case I want to consume it, which I don't believe I will in this demo. At least I'm not planning on it. But anyway, now that we have that up and running, we can go ahead and build Squire. But what we want to do is I'm going to submit a couple of jobs before I go into some of the things that we changed so that we can let these run. Just like last time, I'm going to start by submitting a real GPT job. It's a training job. I'm going to clean up the checkpoint so that we actually have some GPU work to do and make this feel a little more realistic. And then we're going to submit a zombie job, which is basically just a sleep 3600, like sleep for 1 hour job that is going to request a GPU, but it's not really going to use it. Okay, so now that we have that, let's just focus on the README file a little bit, or for a little while. So one of the big changes that I added here was a veridict model. So we basically, I created this thing so that there's a two-axis verdict that is used, or I should say, two axes used to reach a verdict. And the idea here is that we use two different metrics, activity and sizing. The main idea is that the activity measures what the GPU is doing, and the sizing is the resources that are actually being requested. And the core of it is that once you start a new job and we look into how are things going and we're trying to reach a verdict, we start with analyzing, right? So that's the state, the activity state. After a while, depending on the thresholds that we set up for considering something healthy, idle, or zombie, we basically flag it as either healthy, idle, or zombie, right? The idea here is that if something is healthy, we then take into consideration the sizing. Is it over provisioned? Is it right sized? Or is it possibly under provisioned? These things are basically extra metrics that allow us to have a little bit more certainty on our verdict. So they do not change the verdict itself, but basically give us confidence on whether something is really healthy or not. Okay. Now I do want to bring up that this work, like the theory behind it and the problem that it's trying to solve. I basically confirmed that this was a real problem by looking into these two different articles created by NVIDIA. One is a blog post, the other one is an actual article paper. So the first one is making GPU clusters more efficient with NVIDIA data center monitoring tools. This is from November 2025. And the idea is that the NVIDIA infrastructure team built this architecture internally, but to the best of my knowledge, they've never shipped it. And what they did was they joined DCGM telemetry to Slurm job metadata. According to their claims, they were able to cut waste from 5.5% to 1% in production, which is really cool. However, what they built basically was more around enforcement. So they included a Reaper that will kill any idle jobs. But what I'm doing with Squire is a little different. I'm mostly doing read-only accounting. So my idea is not to take action; it's just to basically inform people of waste, right? So that they can make their own judgments and then decide if they want to take action. At least for now. The other paper here is instant GPU efficiency visibility at fleet scale. This is basically overall flop utilization, OFU. What happened is that for this particular paper, separately, around, let me see, May 2026, so NVIDIA published this metric, this new metric that shows why the utilization isn't enough to basically consider if something is stale or really in use and really consuming things. So the OFU derives real flop utilization from two hardware counters and then predicts the application level efficiency to within about 2 percentage points with no instrumentation. So this basically drove me to improve things so that we now also read engine, SM, and tensor activity, and we use that to basically figure out the a verdict and our confidence on that verdict. Okay. All right. Going back here. There's a few different metrics that we are currently monitoring. Some are mandatory, others are optional, right? And they just give us that extra reliability on our assessment, or confidence in the assessment, I should say. So we have the GPU utilization, frame buffer used and free, right? And we use that to basically see the actual percentage consumption. Engine activity, streaming multiprocessor activity, tensor core activity, and even power draw. So these are really cool extra metrics that really help out figuring out whether there's real utilization or not. So the new version uses it. So for thresholds, these are things that you can configure globally when you run Squire. And by default, you have this warm-up ceiling of 15 minutes. That's the grace period. And the zombie after, basically we just configure, it's only consider a job to be a zombie after 2 hours. This is basically based on the research provided from these papers and blog posts. I'm actually gonna, during my demo, I'm gonna change this so that we use a lower amount. We're just gonna target like 1 minute so we can actually see things happen. But as you can see, I believe that these are good defaults, at least based on the research that I'm seeing here from NVIDIA. Okay, so first thing we're gonna do is we are going to no, first thing, sorry. I do want to talk more about the code before I actually start with the demo. So just main thing worth mentioning is that a big change from the gpu-warden, the previous version, is that we now have a verdict here. And the verdict is a central piece of code that doesn't have any dependencies on anything, meaning that it doesn't reach out to network or anything like that. It's a very clean package that whose job is basically to reach a verdict in a central way, so that other pieces, other parts of the code can basically feed into here, and we have a single source of truth for the verdict. And this is where we consider, again, if something is analyzing healthy, idle, or zombie, and then we also the sizing, whether it's right-sized, over-provisioned, or possibly under-provisioned. That's what this verdict is for. I did make a couple of other improvements from the previous version. I did find an issue with the way I was doing things. I was only considering 1 GPU per machine. That's not a real world thing. In real world data centers, you can have like 8 GPUs per machine. So I now take into consideration the index of the GPU cards as reported by Slurm, and to take those into consideration when assessing the actual usage. I did also add some extra protections to the /metrics endpoint. Basically, it became clear that I was hitting the Slurm REST API a little too hard. and Prometheus. So we basically started caching things so that it's more efficient. So we're basically not pounding the underlying services that we need to use to retrieve the data that we need. And also added some protection against an attack in case someone is consuming the metrics endpoint and basically just leaves the connection on without actually sending any data. Now there's a timeout that protects it. And this is very important because at this point I do not have authentication on the slash metrics. Spoiler alert, that will be coming. We will have authentication in a future phase, but right now this is it's still in the proof of concept phase and just making it interesting and useful. So I haven't reached that phase yet. Okay, so let's go into the actual demo. And what we're going to do is we're going to run Squire. As a reminder, we do have 2 jobs currently running. Right, we have that tiny GPT 136 and the zombie 137. And again, if I run Squire, I might just maximize the window so you can see a little better. You can see that we believe that the tiny GPT job is healthy with medium confidence and seems right-sized, but the zombie is still analyzing. Next thing we're going to do is we're going to show another new flag that we have here, --wide, and we're going to also use the $rate. Dollar rate already existed before, but I just want to show those in conjunction. And here what you can see is that when you do the --wide, you can see a reason, because there's an array of reasons that can be attached to the verdict so that you can see why do you think that the activity is in a healthy medium state, and why is it analyzing, right? So what we're going to do to make this a little more interesting, though, is we're going to say that the grace period is just 1 minute. 1 minute is enough to warm up, and we're going to consider the job as a zombie after 1 minute of data. Now, not very realistic, but just good for the demo so that I can actually show you what's going on here. And what you can see now is that with the adjusted grace period and the zombie after thresholds, we consider that job 137 is indeed a zombie with high confidence. Okay. So next thing I want to show is we still have the --act flag. So I want to show that we can watch every 30 seconds. So basically we go into a loop, but I also want to act on it. And what the act does, as I showed in a previous video, is if we detect that there's a zombie, we're going to basically push this to the pod so that other people can query it and find that there was an activity that flags this. So as you can see, there's an event emitted on Slurm worker GPU1 for the job 137. And now it would be a watching, but we're just going to cancel that. And what we're going to do is we're now going to look at the actual message that we stamped into the pod. And as you can see here, there was a GPU allocation idle that came from Squire. That basically says, gives us our verdict and also the reasoning of why we reached that verdict. So there's a little warning there saying, hey, this seems like a zombie job. Okay. Now, last thing I want to show for today is the metrics. So I'm going to basically serve on port 9410 the metrics endpoint that Prometheus could use, and just want to show that we now capture a lot more metrics, right? And we report all those to Prometheus or anything that wants to consume that metrics endpoint. So I think that's pretty much it. So more things coming, but to recap, we now have two-axis verdict system where we take into consideration the activity and the sizing. We look into more metrics to do a better job, like classifying things as a healthy, idle, or zombie. We explain the reason why we reach a certain verdict. There's thresholds that you can configure, but you already could do that before. And we also improved adding cache to the slash metrics endpoint, and also a little bit of protection so that if if there's an attack where we just get people opening connections to the metrics and just leave them open, we don't starve the serve function of Squire by basically closing all those on a certain timeout. So anyway, pretty excited about this. Hope you guys are too. Thank you very much.